This is a small-scale, practical model for Ed Leedskalnin's magnetic flywheel, made in the 1930s at Curl Castle. Would you like to learn more? If so, then please watch this video. As the second part of this series, we're going to study a magnetic flywheel which was made by Ed Leedskalnin at Curl Castle in the 1930s and 1940s. He made it out of old car parts, and it had 24 magnets, NS, alternating all the way around the outside. There was an iron core, and he had a little hand crank by which he could turn it. Now, there have been many mystical theories proposed about this flywheel. Today I'm going to demonstrate that there's no mysticism at all. We can understand it very simply in terms of classical physics. What I've made is a very simple analog NS, 8 neodymium magnets, 50 millimeters, screwed into a little wooden disc with some iron sheets, 2 of them 6 millimeters sitting in the middle, and I've put a wire coil here. Now when this thing spins, it will induce electricity in this wire coil of about 1,000 turns, half-millimeter wire, and it'll make this LED light flash on and off. And this is exactly what Ed did. Let's turn it on and see what happens. Now at low speed, it just starts flashing. We pick the speed up again to about 2 volts, and it's flashing quite brightly. And if we turn it off again, it stops flashing. So this is exactly the same as Ed's complicated flywheel, but we have a much simpler model which we can study in terms of the physics, and there's no mystery involved here. Actually, Ed Leedskalnin would often demonstrate the conversion of mechanical energy into electricity using his magnetic flywheel. To entertain visitors, Ed would connect an electric bulb to this device. When he spun the flywheel, that bulb would light up. And I'm hoping for my visitors on YouTube that you're enjoying yourself now. The bulb's lighting up, and I'm doing exactly the same as Ed. Let's try a more high-powered LED light now. Okay, now for the next stage of this experiment, we're going to put a little more high-powered LED light here that comes on at about 8 volts and goes to 12, rather than the LED which came on at 2 volts as before. So we'll start putting in DC power. It'll start spinning, and we get to a certain speed, the light will start flashing over here. Getting quite bright, isn't it? Very bright. So we're getting at least 8 volts out of it. Now let's put a multimeter on it and see how much voltage we're actually getting in terms of AC. Now as a final part of this video, we're going to attach the wire coil output of this small model for Ed Leedskalnin's magnetic flywheel to a multimeter and see how much AC voltage comes out depending how fast it spins. This won't be as big and powerful as Ed's flywheel, but it's exactly the same physics and we'll get a good idea. So we just turn it on slowly to begin with, and we get about 3 or 4 volts AC. We'll speed it up a little bit more. And we get about 9 or 10 volts AC. So that's plenty of energy, plenty of voltage to charge DC batteries, as Ed did, using this really big flywheel here, which you turn by hand. What we're doing, we're using a DC drive motor down here, which can go faster than a hand spin, but these magnets Ed used are much more powerful than these little magnets here. So it all makes perfect sense. As the flywheel slows down, you can see the voltage goes back to 2 or 1 volts, and the flywheel stops. The reason this thing makes electricity is alternating N and S magnetic fields go past this wire coil. It makes AC current induced one way or the other in this round wire coil here. In terms of AC current being made, We'll change the multimeter to read current rather than voltage. And as we start spinning it, you'll see it start to make current. Here we're getting 100 milliamps at that speed. These little magnets are getting about 200 milliamps at this speed. And we're getting about 270 milliamps at that speed. So this is clearly enough to explain how Ed Leedskalnin charged his 12-volt DC batteries using a larger flywheel of the same kind with 24 NS magnets by hand spinning rather than just 8. It's exactly the same physics. Its flywheel is just a lot bigger. Conclude, some people say that Ed Leedskalnin used not only his hand crank to make this big heavy flywheel turn, but also he had power from his DC batteries, and he would put some pulse DC device around the outside near the magnets that would turn it on and off and make the thing turn. And that's pretty much impossible, because for a flywheel of this kind you have to have 3-phase AC or DC power to make it turn. Now I'm going to take a magnet here and I'm going to show you how that works. You put this magnet up and you see the two red ones align. The only way to make it spin is if that red magnet rotates around and goes sideways. Line up the red one and then you make it go around. That's the only way to make the thing spin. You can't just come up to the thing and go on and off, on and off. You can make it move around a little bit, but you can't make it spin. You have to have a rotating magnetic field. So Ed had to use the hand crank, but he made plenty of electricity. So we've learned everything we need to know today about Ed Leedskalnin's magnetic flywheel in terms of classical physics, and there should be no mystery left to anyone.